Inequalities Part 2. So we did Part 1. I talked briefly about and versus or. Now we're going to understand it fully. You're going to see all the possibilities of both, okay? And how it affects your answers. So we're going to start off. So we're basically combining two inequalities with either the word and or with the word or. And we're not going to use the three-sided approach, which is just and. We're going to just use two separate inequalities with the word and or with the word or. And you're going to see, we're going to do the same ones for and the same ones for or. And you're going to be able to see how they change depending on it being and or. Question?
Wait, so can we, like, you said, I looked back at my notes and you said that we can use the word intersection for and the word union
Correct.
for or. So,
Correct.
like, how does that play?
You'll see.
Okay.
You'll see as we go. Okay, so, here's our first one. Make sure we're on here. Okay. So, let's say we have x is less than negative 4 and x is greater than 5. And over here for number 2, I'm going to do x is less than negative 4, or, you don't have to put the ors and the ands in boxes, I'm just doing it to make it stand out. And, or, x is greater than 5. Let's see how the answers differ between the two words, okay? So immediately I have to graph this, right? It's all ready. I don't have to solve for x because there's nothing to solve. It just is already done. Eventually, on the homework, some of them will have to be solved. It might say 2x minus 7 is equal to negative 10, and then you have to solve for x. And then you get this. Does it make sense? You get this, and then you graph it. You want to say x is less than, or x is greater than, or x is less than or equal to, or whatever. So that already says it, so I'm ready to graph. Here's my graph. Here's my negative 4, and here's my 5. Okay, x is less than negative 4. Is x on the left side of this?
Yeah.
It's on the left. Therefore, I can use that direction of the inequality sign. It looks like a little arrow pointing to the left, right? I know I'm going to go that way. It does not equal, so it's going to be an open circle. So I'm going to do it right here above it. Open circle, and it goes to the left. Piece of cake. This one says x is greater than 5. It does not equal 5. It's got to be an open circle. And greater than 5, like a million is greater than 5, so that's that direction. So I go that way, right? X is on the left, so I see the arrow of that inequality sign is like an arrow pointing to the right. Right? Okay, this says and. So Bo asked about the word intersection. Where do these two lines intersect? They don't. There's no intersection.
So it's no solution.
So it's no solution. Exactly. So no solution. And that's all you write. Okay, it makes sense? Just a 5? Mike, that makes sense? You get it? Okay. Awesome. Okay. Now let's see what it does with or. It's the same thing. I can graph the same thing, right? So I've got negative 4, and I've got 5, and it's open circle to the left, and open circle to the right. Same graph, because it's the same problem. The only difference is the interpretation. Or says that we can unite any answer of either of the two inequalities. We can unite them. Union. Union is like uniting. So it says, oh, if I had something that was less than negative 4, then it would be a solution to this. If I had something that was greater than 5, like 7, it would be a solution of this. Even though it's not, 7 is not less than negative 4. We get to unite them. It doesn't matter which it is. You don't have to have both in common. You only need one of them. Does that make sense? You see what I mean? Or, that's what or means. Remember when I asked you, how, raise your hand if you're wearing blue or pink.
Oh, I don't know.
Right? And somebody was not wearing blue, but they were wearing pink, so they raised their hand. Another person was not wearing pink, but they were wearing blue, and they raised their hand. Right? Doesn't matter that the blue didn't have the pink. Didn't matter that the pink didn't have the blue. It's or. So or means either one is fine. This is not a solution in here, but everything else is. Does that make sense? So therefore, the way you write it is this. You say in set notation, you say the set of all x's such that. And then with or, the weird thing is you just rewrite this. It's the weirdest thing, but you just rewrite that. Because there's no other way to say it. Right? So you just say x is less than -4 or x is greater than 5. And then you have your end of your set notation. Yes? Please.
Will it always be like that, or will it be different? It'll be like,
For the ors, it will sometimes be different. But in this case, it's like, you'll see as we move through. Just make sure you take good notes. So okay? You're all taking good notes, right? Okay. All right. That's number 1 and 2. Can I erase?
mm-hmm. Yep.
Everybody says okay? I'm going to erase. Okay, 1 and 2. Now we'll do 3 and 4. Let's see, we just did that way. Okay, 3. All right, let's say we had x is greater than -5 and, then we're doing and, x is less than 10. Okay, and number 4, we're going to do x is greater than -5 or x is less than 10. Okay, same problem, the only difference is and versus or. Okay, I'm all ready to graph it because it's already solved for x, right? I don't have to do any math in this case, right? So here's my -5, here's my 10. X is greater than -5. What? Yeah, whatever. Okay, go this way forever. Notice I didn't just go like this. I didn't go like this. I didn't go, right? That's not going to help you, right? That is not going to help you. A little teeny arrow. You want the arrow to go the whole way because you want to see the intersection, right? That's what end's all about. Where are they overlapping? Where do they intersect? So you want to see the whole arrow all the way through the number line. And then it says x is less than 10. Open circle, less than 10, all the way this way.
that was so squeaky.
Okay, so now, where do they intersect? The only place they're both true is this area here. So that's my answer. I bring it down to the number line and I make a big heavy line like that. And then I write it. My solution would be, my answer, would be the set of all x's such that, notice x is all of this in here, right? So I'm going to put my x there. And then it's really easy to write it. I put this, the two boundary lines, right? The -5 and the 10. And I have my x in the middle. And x is bigger than this, right? And x is littler than that. Yes? You see what I mean? All right, and that's your answer. It's not that hard. You get
I
it?
need to learn how to do the set. I can't do it. The little-
Yeah, it takes a little practice.
You just do it and you
It takes a little practice.
Bo, John S.
Alright.
and John Doc.
Okay, here we go. Here we go. We got to keep moving, guys. We got to keep moving. We got to keep going. So -5. I'm just going to graph it really fast. The same thing. X is greater than -5, and x is less than 10. Okay, it's the same graph. But the word is or. So Silas, what would you say is the answer?
It's the same thing.
You're uniting both of them.
So it can be either.
So think about it. Think about it. Think about it. Uniting means, union means we're just going to bring them both down to the line. Right? And if there's any place that's not at least covered a little bit, then that's a problem. But yes. Infinite solutions, yes! Well done. Because look, if I brought these both down, there would be a line everywhere. Do you see what I mean? Because this one is going forever that way, but I know there's an open circle here, but this one covers it. It goes right through the open circle, right? Right? So it's going forever this way, and this one, it's going forever this way. There's an open circle there, but this line covers it. Do you see what I mean? So the whole thing would look like this. Would be one big line with an arrow going in both directions.
That's pretty good.
Do you see that? Does that make sense?
No.
You get it?
Yeah.
Rowan, you get it? Does that make sense to you, really?
It makes them a little sense.
Did you draw that?
Yeah.
You're drawing these? You got to draw these if you haven't. All right, so here's the answer. I'm going to show you a shortcut for writing all real numbers. Infinite. You could say infinite solutions, but this is typically how you'd say it. The set of all x's such that x is all real numbers.
Just do an infinity sign.
And the reason I have to say real numbers is there are also unreal numbers, okay? But there's a shortcut for writing this, all right? And it's this: the set of all x's such that x equals an uppercase cursive R.
Wait, I can't do that.
Whoa.
I can do that.
All right, then do that one.
Can it be cursive upper? Oh no, that is
Cursive upper.
Thank you.
Okay,
Thank you.
Leo is probably our only one who can do it, right?
Wait, I can't do that. Wait, Jared, go where's the R?
I can do it.
It's like this. You go like this.
Okay.
You go around.
All right, good.
I get it.
We're running out of time. Can I erase? No. 5.
Yeah.
X is less than 2, and so write this down, guys. Stay focused, guys. Micah, make sure you're writing this stuff. Stay focused. Stay focused. I'm hearing a lot of talking. Who's talking? Let's have it quiet. I'm gonna.
Can we do one that you need to solve?
Okay, here we go.
Can we not?
Well,
You erased it.
yes, I did. You can look at Tom's. X is less than 7. All right? And here we go. 6. X is less than 2, or X is less than 7. All right, so graphing is pretty easy, right? Here's my 2, here's my 7. X is less than 2. It goes that way. You agree with me?
Yes, I agree.
Yes? X is less than 7. It goes that way, right? You agree with me?
Yes.
All right. Sachi, what's the answer? Guys, wait. I'm asking Sachi for the answer. Listen for her answer. X is less than 2, right? The only place it starts to have intersection where they're both true
It's past 2.
is past 2.
It's
So
like on-
this is not part of the answer. Only this is. Does that make sense? Because and means they have to both be true. They're both true starting here going that way. So my answer would be the set of all x's such that x is less than 2. Easy, right? Confusing, but easy. All right, same graph. I've got 2 and I've got 7. Where am I? What am I doing? 4. Okay, so x is less than 2. X is less than 2. X is less than 7. Shh. Okay. Yellow. What's my answer now? For or. Either one can be true. So all possibilities are true for this that have lines. And meant only when there's intersection, when there's overlap. This means anywhere where there's one line or 2 lines, it's true. Therefore, this is where it starts. Because there's only one line here and there's 2 lines here. It doesn't matter that there's 2 lines, you just need 1 line. Right? Does that make sense? You get it? Gavin.
Less than or equal to
X has, yeah, for or means X is less than 7. Because less than 7, 2 is less than 7. X is less than 2 is encompassed in X is less than 7. Do you see what I mean? It's,
So then,
right? So,
would it be,
because all I need is one line. I need 2 lines for and, right? Using my vertical thing, I need 2 lines. Boom, it starts there. For or, all I need is 1 line. No line, no line, no line, no line. Ah, I got a line now. It starts there. It goes. Starts. It starts. Do you see what I'm saying? Oh, I got 2 lines. I don't care. I got. This is an or. So I only need 1 line. And means I need 2 lines. Okay? All right? So my answer is the set of all x's such that x is less than 7. And I'm done. You only need 1, and the 1 starts here. And just because there's 2 doesn't matter. It keeps going forever and ever, right? So that would be your answer.
A lot of rules.
Now, if I gave you one that had to be solved, do you guys know how to do those?
yeah.
You just solve for x, right? You subtract from both sides. You divide from both sides.
Oh, yeah.
So, all right, so don't leave yet because I have homework to hand out.
Oh, no.